Explain him the.
Yeah, you can start. Yeah. Hi, I'm Suresh. I have completed my BTech from IIT Guwahati. I'm teaching for the past 6 years with various institutions. Currently, I'm working with Fiji as a professor in mathematics. Today, let's discuss about the quadratic equations. Quadratic equations. First, let's see what is the definition. A quadratic equation is defined as ax squared plus bx plus c is equal to 0, where a is not equal to 0. Here, b and c may or may not be equal to 0, but a should never be equal to 0. That is a condition. For example, 2x squared plus 3x plus 4 is equal to 0, or x squared minus 5 is equal to 0, or x squared plus 2x is equal to 0. These are the examples for the quadratic equations. So, in this quadratic equations, we have something called as the roots. The roots are nothing but those values of x which would solve the equation. That is, let's say we have an equation 2x squared plus 8x plus 8 is equal to 0. Let's say we have an equation 2x squared plus 8x plus 8 is equal to 0. So this equation, if we substitute x as let's say like minus 2, if we substitute x as minus 2, it will satisfy the equation. So if we substitute and check it out, 2 into x square, that is 2 into 4, plus 8 into minus 2, that is 16, plus 8. So 16 minus 16, that will become equal to 0. So such numbers which satisfy the equation, we call them as the roots of the quadratic equation. A quadratic equation can have a maximum of 2 roots. So let's say I call those roots as alpha and beta. Then in that case, we have a relation between the roots. That is, the sum of the roots, alpha plus beta, will be equal to minus b by a. So here b is nothing but the coefficient of x, as you can see above, and a is nothing but the coefficient of x square. And similarly, the next relation would be the product of the two roots, that is alpha multiplied by beta, that is equal to c by a, where c is the constant and a is the coefficient of x square. So this is a basic relation. And let's say you are not given the equation first and ask the roots, rather you are asked to do the opposite. That is, you are given the roots and you are asked to find the equation. So in that case, we will take this alpha plus beta as yes, and that is the sum of the roots, and alpha multiplied by root beta as p, which is the product of the roots. So once we are given the roots, we will be able to clearly find S and P. That is, let's say alpha and beta, the roots given to you are 2 and 1. Then the sum of the roots, that is alpha plus beta, would be 2 plus 1, which is equal to 3. And the product of the roots, which would be 2 multiplied by 1, that is equal to 2. So when these two things are given to you, you will be able to write the equation as x squared minus sx plus p is equal to 0. So what is S and P here? S is the sum of the roots and P is the product of the roots. As we were discussing, if those two roots are 1 and 2, then in that case S will be 3 and P will be 2. Therefore the equation would be x square minus the S is 3 in our case, in this particular example that we are taking, and the product is 2 in this case. So the quadratic equation whose roots are 1 and 2 will come out to be x square minus 3x plus 2 is equal to 0. Right? So this is how you will write the equation when the roots are given to you. Now, Using this basics, we will try to do some problems. Let's say we are given that ax squared plus bx plus c is a quadratic equation whose roots are alpha and beta, right? Whose roots are alpha and beta. So this is given to us, that is alpha and beta are the roots of the above equation. Now we need to find an equation whose roots are alpha plus 2 and beta plus 2. So let me repeat the question one more time. So we are given a quadratic equation ax square plus bx plus c is equal to 0, and it's also given that the roots of that equation is alpha and beta. Now we need to find out the equation whose roots are alpha plus 2 and beta plus 2. So let's do that. So since we are already given that the roots of the equation are alpha and beta, we know that alpha plus beta is equal to minus b by a. And alpha multiplied by beta is c by a. So as I said, now we need to find the equation whose roots are alpha plus 2 and beta plus 2. So what do we have to do? We have to find the sum of the roots and the product of the roots. So how do we find that? We will try to find this s and p with the help of these two expressions, that is alpha plus beta is equal to minus b by a, and alpha multiplied by beta is equal to c by d. Right. So what are our two roots? Our two roots are alpha plus 2 and beta plus 2. So let me write the sum. The sum in our case, s would be alpha plus 2 one root plus the other root, that is beta plus 2. Or the sum in our case, we can rewrite that as alpha plus beta plus 4. So alpha plus beta, as we have seen, is equal to minus b by a plus the 4, we will keep it as it is. So for the equation that we are going to write, the s would be minus b by a plus 4. And the product also we need to find. So for the equation that we need to write, the product will be alpha plus 2 multiplied by beta plus 2. So if I multiply these two things term by term, then I'll get this expression as alpha multiplied by beta, that is alpha beta, plus 2 alpha plus 2 beta, which I am writing it as 2 into alpha plus beta, 2 multiplied by 2, that is equal to 4. Right. So now we know that alpha multiplied by beta is c by a. That is the product of the roots for the given equation in the question. And alpha multiplied by alpha plus beta is minus b by a. So let me substitute that as well. Plus 4. So for the equation that we are going to write, the product is c by a minus 2b by a plus 4. So now given that we have found out what is s and p, that is what is the sum of the roots and the product of the roots for the equation that we are going to write, we can directly write the equation as x squared minus sx plus p is equal to 0. That is equal to 0. So we have found the S and P. Let's substitute it here. X squared minus of S is minus B divided by A plus 4, the whole multiplied by X, plus the product we found out as C by A minus 2 times B by A plus 4, so is equal to 0. Just to simplify, if I multiply the whole thing by A, I'll get the expression as ax square minus 4a minus b into x plus c minus 2b plus 4a is equal to 0. So we wanted to find the equation whose roots are alpha plus 2 and beta plus 2, and that equation is ax squared minus of 4a minus b multiplied by x plus c minus 2b plus 4a is equal to 0. So this is the method number 1 to do this question. We also have a method number 2 to do this question, which would be comparatively very simple. So let's try to do that as well. So this method, we call it as the method of transformation. So in this method, what we do, we take the initial equation, that is the equation given in the question, ax square plus bx plus c is equal to 0. It's given that alpha and beta are the roots, as we have discussed before. Alpha is a root, it means that a alpha square plus b alpha plus c is equal to 0. So the meaning of that root is, if I substitute x as alpha, this expression should be equal to 0. Now, in this method, what we do, we have to find an equation whose roots are alpha plus 2 and beta plus 2. So what we do, we substitute x as alpha plus 2. Or the other way of saying the same thing, I'll substitute alpha as x minus 2. So if I substitute that in the equation, what will I get? So if I substitute that, I'll get a into alpha. I'm replacing that as x minus 2 the whole square plus b into x minus 2 plus c is equal to 0. Right. So now, if I expand this expression, that is x minus 2 the whole square, then if I compare it with the solution that we have got from the first method, both will be the same. That is a into x minus 2 the whole square. I'm applying the formula a minus b the whole square. If I apply that, I'll get this as a into x square minus 4x plus 4. That is x minus 2 the whole square. We can write it as x square minus 4x plus 4 plus b into x minus 2 plus c is equal to 0. Now let's collect the coefficient of x square. Coefficient of x square is only present in one place. That is ax square is there. So let me write that. So a into x square. Let's look at the x. X we have here, that is minus 4x into a. So let me write the minus 4 and a. I have the bx here. Since I have taken the minus outside, I can write this as minus b. So 4a minus b. So x term is over. Minus 4a minus b into x plus 4a, whatever the leftover terms I'm writing, 4a minus 2b plus c is equal to 0. So this is the same answer that we have got from the method number 1. So this method we call it as a method of transformation. This is comparatively easy because we don't need to do so much of calculation. We'll simply substitute the value of alpha as x minus 2 here, and we will be able to do the question. So I hope you have understood this method, and you will be able to do many questions in the same way. For example, in the same question, we can also find the equation whose roots are 1 by alpha and 1 by beta by applying this same method, right? So that's all we will discuss for today. And we have, like so many other things in the quadratic equation as well. For example, the nature of the roots, quadratic expression, sign of the quadratic expression, location of the roots, cubic equation, and the miscellaneous equations. So these things we'll discuss at a later point of time. And thank you for watching this video. I have cut it once. Is it okay? Yeah, yeah, I completed, but I am pressing the int mark. Nothing is happening. Probably this is a problem in my computer.